Chemical equations. Let us first look at a chemical reaction. In the activity 2, a colorless solution of zinc sulfate, ZnSO4, is formed on addition of zinc dust to the blue solution of copper sulfate, CuSO4. This chemical reaction can be written in brief as follows. Aqueous solution of copper sulfate plus zinc dust gives aqueous solution of zinc sulfate plus copper. Statement 1. This simple way of representing a chemical reaction in words is called a word equation. A word equation can be written in a further condensed form by using chemical formulae as follows. CuSO4 plus Zn gives ZnSO4 plus Cu. Statement 2. The representation of a chemical reaction in a condensed form using chemical formulae is called as the chemical equation. In the equation, copper sulfate, CuSO4, and zinc, Zn, are the reactants. They react with each other to form copper particles, Cu, and a solution of the colorless zinc sulfate, ZnSO4, as the products having totally different properties. The ionic bond in the reactant CuSO4 breaks and the ionic bond in the product ZnSO4 is formed during the reaction. Writing a chemical equation. Let us now see the conventions followed while writing a chemical equation. 1. In a chemical equation, the reactants are written on the left-hand side while the products on the right-hand side. An arrow heading towards the products is drawn in between them. This arrow indicates the direction of the reaction. 2. If the reactants or products are 2 or more, they are linked with a plus sign in between them. For example, in the equation 2, a plus sign is drawn in between the reactants CuSO4 and Zn. Similarly, a plus sign is drawn in between the products ZnSO4 and Cu. 3. To make the chemical equation more informative, the physical states of the reactants are indicated in the equation. Their gaseous, liquid and solid states are indicated by writing the letters G, L and S respectively in the brackets. Moreover, if the product is gaseous, instead of G, it can be indicated by an arrow pointing upwards. If the product formed is insoluble solid in the form of a precipitate, then instead of S, it can be indicated by an arrow pointing downwards. When reactants and products are in the form of solution in water, they are said to be present in aqueous solution state. This state is indicated by putting the letters AQ in brackets after their formula. Thus, the equation 2 is rewritten as equation 3 shown CuSO4 aqueous plus Zn solid gives ZnSO4 aqueous plus Cu solid. Statement 3. 4. When heat is to be given from outside to bring about a reaction, it is indicated by the sign written above the arrow that indicates the direction of the reaction. For example, the reaction in which slaked lime is formed on heating limestone is written as follows. CaCO3 solid on heating gives CaO solid plus CO2 is released. Statement 4. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as follows. CuSO4 aqueous plus Zn solid gives ZnSO4 aqueous plus Cu solid plus heat. Statement 5. 5. It is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reactions. These conditions are indicated below or above the arrow indicating the direction of the reaction. For example, the reaction of a vegetable oil takes place at the temperature of 60 degrees Celsius with hydrogen gas in presence of the Ni catalyst and is written as follows. Vegetable oil liquid plus H2 gaseous gives 60 degrees centigrade Ni catalyst, Vanaspati ghee solid. Statement 6. 6. Special information or names of reactants, products are written below their formulae. For example, copper on reaction with concentrated nitric acid gives reddish colored poisonous nitrogen dioxide gas. Cu solid plus 4HNO3 aqueous gives CuNO3 aqueous plus 2NO2 gaseous plus 2H2O liquid. Statement 7. However, on reaction with dilute nitric acid, the product formed is nitric oxide gas. 3Cu solid plus 8HNO3 aqueous dilute gives 3CuNO3 aqueous plus 2NO gaseous plus 4H2O liquid. Statement 8. Try this. Apparatus: test tube, conical flask, balance, etc. Chemicals: sodium chloride and silver nitrate. Procedure: 1. Take sodium chloride solution in a conical flask and silver nitrate solution in a test tube. 2. Tie a thread to the test tube and insert it carefully into the conical flask. Make the conical flask airtight by fitting a rubber cork. 3. Weigh the conical flask with the help of a balance. 4. Now, tilt the conical flask and mix the solution present in the test tube with the solution in the conical flask. 5. Weigh the conical flask again. Which changes did you find? Did any insoluble substance form? Was there any change in the weight? A word equation is written for the above activity as shown. Silver nitrate plus sodium chloride gives silver chloride plus sodium nitrate. The above word equation is represented by the following chemical equation. AgNO3 aqueous plus NaCl aqueous gives AgCl precipitate white plus NaNO3 aqueous. Statement 9. Do you know? Silver nitrate is used in the voter's ink. Find out. What are the other uses of silver nitrate in everyday life? Answer. The other uses of silver nitrate in everyday life are as follows. Silver nitrate is used as a reactant in the laboratory. Silver nitrate is used to prevent infection in wounds and skin burns. Balancing a chemical equation. Complete the table aside on the basis of the equation 9. It is seen that the number of atoms of the elements in the reactants in this equation is same as the number of atoms of those elements in the products. Such an equation is called a balanced equation. If the number of atoms of each element is not the same on the two sides of the equation, it is called an unbalanced equation. Always remember, in any reaction, the total mass of each of the elements in the reactants is same as the total mass of each of the respective elements in the products. This is in accordance with the law of conservation of mass that you studied in the previous standard.